Page 323, question number 7. In this case, we have a pulley system. So we have our 2.4 kilogram mass up in the air, 1.40 meters above the ground. We have the 1.5 kilogram mass on the ground. Now they're attached by a rope. We're not worried, considered an ideal rope, so we don't worry about the mass of the rope. This mass obviously is going to fall down when released. The 1.5 kilograms is going to go up. Because they're attached by the rope, the speed of the 2.4 kilogram mass and the 1.5 kilogram mass will be the same when they stop moving. So when this one hits the ground, this one's going up. At that point, the two will have the same velocity. And you'll see where that becomes important in a second. So we know that our mechanical energy at the start will equal our mechanical energy at the end. When we start off, we simply have the gravitational potential energy of object A, our 2.4 kilogram mass. At the end, our object B is going to go up in the air, so we're going to have gravitational potential energy due to B, and we're going to have kinetic energy. Now, both of these are going to be moving, but they're going to be moving at the same speed. So I'm going to call that kinetic energy AB. So in this case, that's what we're looking for. So our kinetic energy for object A and object B will equal our gravitational potential energy of A minus the amount of energy, the gravitational potential energy of B. So that's the energy required to lift B up into the air. So substituting in our values, we're going to have mass of A times gravity times the height minus mass of B times gravity times the height. So we get 2.4 kilograms times 9.81 meters per second squared times the height, 1.4 meters, minus our mass, 1.5 kilograms times gravity, 9.81 meters per second squared, times the height, 1.4 meters. Because obviously when this goes down 1.4 meters due to the rope, this one has to go up 1.4 meters. So putting that into our calculator, we get 2.4 times 9.81 times 1.4 minus 1.5 kilograms times 9.81 times 1.4 gives us an energy of 12.3606 joules. So to solve for our kinetic energy, it is going to be 12.4 joules of kinetic energy when when our mass A hits the ground.